This is 2021 Spring AMC 10A Problem 12. Two right circular cones with vertices facing down as shown in the figure below contains the same amount of liquid. The radii of the tops of the liquid surfaces are 3 cm and 6 cm. Into each cone is dropped a spherical marble of radius 1 cm, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of the liquid level in the narrow cone to the rise of the liquid level in the wide cone? So this problem is saying, to simplify this problem is actually just saying we want to figure out the change in the height, the ratio of the change in height in this cone to the ratio of the change in height in this cone. So how do we figure that out? Well, maybe we should figure out the ratio of the original heights. Let's just call the original heights H1 and H2. Now we know that the volume of the liquid is the same because it literally says the same amount of liquid. So therefore the volume, which is 1/3 H1 pi r squared, which is 9 pi, is equal to 1/3 H2 36 pi, which is pi r squared for this cone here with H2 as a height. So we simplify that. H1 is going to be equal to 4H2. So that's actually good. We have a relationship that is, well, quite clear. H1 to H2 is going to be, H1 to H2 is going to be 4 to 1. So it's going to be 4 to 1. So we can consider this option E over here, but we're not really sure. Let's just confirm it logically. So essentially what happens when I add the 1 cm radius, when I add the 1 cm the 1 cm radius marble in, is that the volume is increased by the volume of this marble, right? So the volume is increased by 4/3 pi r cubed, which is just 4/3 pi. Now the increase of this 4/3 pi thing is going to be divided into the increase in the radius of the cones and the increase in the height of the cones. Now, however, no matter how much the radius and height actually is, we know that this number is actually the same for both cones. The volume still stays the same, which means that the heights still have the same proportion, because as long as the volume stay the same, so we have, it's sort of like the slope of the increasing rate of our cones. So as long as the volume stays the same, H1 is always going to be 4H2, no matter what H1 and H2 are, as long as their volumes are the same. So therefore, this means that the increase to maintain the balance in proportion of H1 equals 4H2, H1 and H2 have to increase in the ratio of 4 to 1, which means that our answer is going to be E. So thanks for watching. Bye.